Hey everyone, and welcome. Today, we're going to dive deep into the incredible technology that lets computers read, understand, and even generate human language. Yep, we're talking all about natural language processing.
I mean, really think about it for a second. You ask your smart speaker to play a song, you type a question into Google using everyday language, your email somehow knows what's spam. How in the world does that actually work? It feels a little bit like magic, right? Well, it's not.
The secret sauce behind all of this is something called natural language processing, or NLP for short. You can think of it as the ultimate translator, building a bridge between our messy, nuanced human languages and the cold, hard logic of a computer. And let me tell you, it's one of the most exciting fields in AI right now.
So what is it really? Well, NLP is this amazing blend of computer science, artificial intelligence, and even linguistics. The goal sounds pretty simple. We want to give computers the ability to understand what we're saying. But it's not just about reading the words. It's about getting the meaning, the context, the intent behind them, and then actually doing something useful with that information. Okay, so here's our game plan. We're going to start by peeling back the curtain on how computers even begin to read. Then, we'll look at the core tools of the trade. After that, we'll see how NLP is already all around you. And finally, we'll peek into the future and see where this conversation is heading. All right. So how on earth do you teach a machine to read? You can't just hand it a book, right? No, it's a really methodical, step-by-step process of breaking our language down into something a computer can actually crunch. First, you need data, a lot of data. We're talking about scraping massive amounts of text from websites, books, social media, basically a huge chunk of the internet. Then comes a step called preprocessing. This is like the ultimate spring cleaning for text, getting rid of all the junk so the computer can focus. After that, we have to turn words into numbers, because at the end of the day, computers speak math, not English. And finally, you feed all of that prepared numerical data into a machine learning model, which chews on it and starts to figure out all the patterns and structures of our language.
You know, a really important part of that cleaning step is getting to the core of a word. One method is called stemming. It's kind of like a brute force approach. It just chops off the end of a word. So studies becomes studi. It's fast, but studi isn't a real word. A much smarter way is lemmatization. This uses a dictionary to find the actual root word or lemma. So studies correctly becomes study. It takes a little more time, but the accuracy is way, way better.
So once the words are all cleaned up, how does a computer actually start to understand what they mean? This is where a truly revolutionary idea called word embeddings comes in. Just picture a giant, complex 3D map. On this map, every single word is a point. Words with similar meanings, like king and queen or dog and puppy, are plotted super close to each other. Words that are totally different, like king and cabbage, are miles apart. This was a massive breakthrough, because for the first time, it let machines see the relationships and context between words. It's how they can even understand analogies.
Okay, so now that the computer can get to the root of a word and see how words relate to each other, we can start building some seriously powerful tools. These are the fundamental building blocks that power almost all the language features we use every day. And this toolkit is just packed with amazing skills. You've got sentiment analysis, which can figure out the emotion in a sentence. There's machine translation, for translating languages. It can even summarize a huge article for you. Or, of course, detect that annoying spam in your inbox. Each one of these is like a specialized superpower for the AI. Let's just zoom in on sentiment analysis for a second, because this one is absolutely huge, especially for businesses. At its core, it's about reading a chunk of text, like a tweet or a product review, and figuring out the vibe. Is it positive, negative, or just neutral? So, take this review, for example. An NLP model would scan this and immediately lock onto words like amazing, helpful, and love. Based on those powerful emotional cues, it can say with high confidence, hey, this is a positive review. Now imagine doing that for millions of reviews in seconds. That's the power we're talking about.
Another really cool tool is named entity recognition, or NER. The best way to think about NER is like a set of digital highlighters. It reads through a text and automatically finds and tags important things, like names of people, companies, places, and dates. This helps the computer pull out the key facts from a document and organize them in a structured way.
And here's the thing. This isn't some futuristic sci-fi concept. NLP is already woven into the fabric of your daily life, and a lot of the time you probably don't even realize it's there.
Seriously, every single time your spam filter saves you from a junk email, that's NLP. When you ask Siri or Alexa for the weather, that's NLP. When Grammarly fixes your typo, or a chatbot on a website answers your question at 2 a.m., Yep, you guessed it, that's NLP at work. It's the invisible engine making our technology so much more intuitive. And its impact goes way beyond our personal gadgets. In healthcare, NLP is being used to analyze mountains of electronic health records to spot disease patterns. In retail, it's digging through all that customer feedback we talked about. Finance uses it to analyze news and predict market trends. And in the legal world, it's helping lawyers find that one crucial piece of evidence buried in thousands of documents. It's a game changer everywhere.
And the scale of these new models is just mind-blowing. Get this. The famous GPT-3 model has 175 billion parameters. What's a parameter? You can think of it like a tiny little dial that the AI gets to tune and adjust as it learns from all that data. Having 175 billion of those dials is what gives it the incredible ability to generate text that feels so spookily human.
So where does this all go from here? Well, to really get a sense of the future, we have to take a quick look back at the past. The story of NLP has been this wild, accelerating ride from super simple rules to the unbelievably complex AI we have today. It really kicked off in the 50s with these rigid rule-based systems. Then in the 60s, we got early chatbots like Elijah, which were pretty clever tricks of pattern matching. The 90s were a huge turning point with the statistical revolution. We started letting the data do the talking instead of writing rules by hand. And then the 2010s hit, and the deep learning era completely changed the game with models that just blew everything else out of the water.
And that whole journey, that entire history of innovation, is what led us directly to this moment. The powerful generative AI models that are making headlines everywhere, they didn't just pop up overnight. They are standing on the shoulders of nearly 70 years of brilliant research and hard work.
But we are definitely not at the end of the road. There are still some huge challenges ahead. How do we build models for languages that don't have billions of web pages of data? How do we crack open the black box so we can actually understand why an AI made a certain decision? And what about the very real problems of bias in the training data, or the massive environmental cost of training these giant models? These are the big questions everyone is working on now.
When you think about it, we've gone from translating just 60 Russian sentences to creating AI that can write entire novels. The progress is just staggering. We've taught these machines how to listen, how to understand, and now how to speak back to us. So I guess the final question really isn't for the machines, it's for us. As they continue to master our most human skill, language, what will we choose to say to them?